A nuclear bomb is an explosive device that's incredibly destructive because of the nuclear reactions occurring within it. That destruction is a result of an enormous energy explosion that's released as a result of nuclear fission, nuclear fusion, or a combination of the two processes. Fission bombs are commonly referred to as atomic bombs or atom bombs, whereas fusion bombs are referred to as thermonuclear bombs or more commonly hydrogen bombs. In thermonuclear bombs, part of the energy is released by nuclear fusion, and the energy obtained from fusion and fission reactions is based on differences in the nuclear binding energy. Atomic bombs work through the fission process, which is that when bombarded by neutrons, certain isotopes of uranium and plutonium will kind of split into atoms of lighter elements, which is the process of the fission, or like the breaking apart into smaller. In addition to the formation of lighter and smaller atoms, free neutrons are also emitted in the fission process, as well as a considerable amount of energy. The complete fission of 1 kilogram of uranium or plutonium produces about 17.5 kilotons of TNT equivalent explosive energy, so quite a lot of energy. In an atomic bomb, a small number of neutrons are given enough energy to collide with nuclei in order to begin the fission, thus producing more free neutrons, making a chain reaction. The continuing process whereby neutrons emitted by fissioning nuclei induce fissions in other fissile nuclei, which is called a fission chain reaction. If the number of fissions in one generation equals the number of neutrons in the preceding generation, the system is said to be critical. Supercritical systems have a number greater than 1, while subcritical systems have a number less than 1. In nuclear reactors, the number of available fissionable nuclei in each generation is very carefully controlled so that there's not a runaway chain reaction. However, in atomic bombs, rapid growth in the number of fissions is desired. So the minimum mass of fissile material necessary to sustain a chain reaction is called the critical mass. If the mass is greater than the critical amount, it's supercritical. If the mass is less than the critical amount, it's subcritical. So atomic bombs are made by nuclear fission, while thermonuclear bombs are fusion weapons, or weapons that are a result of fusion reactions. So nuclear fusion is the joining or the fusing of the nuclei of two atoms to form single heavier atoms. So while fission is the breaking apart, fusion is the coming together. The mass of the products of a fusion reaction is smaller than the mass of its reactants. At extremely high temperatures, the nuclei of isotopes of hydrogen can combine so as to form heavier elements and release considerable energy, thus why it's called the hydrogen bomb. When hydrogen atoms fuse, the nuclei must come together. However, the protons in those nuclei tend to repel each other as they have the same charge, that charge being positive. So it's the same concept as if you had two magnets that are the same charge. When you bring them together, they're going to fight and repel against each other. So to achieve fusion, special conditions need to be created in order to overcome that tendency of repelling and allow for fusion. So the kinetic energy of the nuclei is sufficient to overcome the long-range electrostatic repulsive force between them so that they can get close enough for the shorter range kind of strong force to attract and fuse the nuclei, why it's called thermonuclear. Several conditions that have to be present so that they can fuse is high temperature, which gives the hydrogen atoms enough energy to overcome the electric repulsion between the protons, and then high pressure squeezes the hydrogen atoms together. In thermonuclear weapons, the required temperatures and density of the fusion materials are achieved with a fission explosion, which is why its thermonuclear weapons have both fission and fusion. In these weapons, the fusion material can be incorporated directly in the fissile core or external to the fissile core, or both. Typical thermonuclear weapons are constructed using a two-stage design with a fission primary, which is also called the trigger, and a physically separate component, which is called the secondary. Both the primary and the secondary are contained within an outer metal core, or metal case. The radiation from the fission explosion of the primary is contained and used to transfer energy to compress and ignite the secondary. Some of the initial radiation is absorbed by the inner surface of the case, and subsequent radiation from the primary is confined between that boundary of the case and then the outer surface of the secondary capsule. The fission and fusion processes in the secondary are more efficient and effective than the ones in the primary. The secondary generally contains a composite of fusion and fissile materials. Nuclear fusion reactions require a lot of energy to begin. It has to have so much poured into it. But at the same, in the same way, they have the ability to produce enormous amounts of energy and just enormous destruction from that energy release. So a thermonuclear bomb, in conclusion, in short, is an uncontrolled fusion reaction in which enormous amounts of energy are released. So nuclear weapons, as I've said several times, have a vast amount of explosive energy that can be released, and the effects they have, like extremely high temperature and like the thermal radiation and then radiation, is destructive on a massive, large scale. The impact of the nuclear bomb depends on a lot of things, like the design of the weapon. So is it fission, is it fusion, and its yield, where it explodes, where's the detonation, is it in the air, is it on the surface, is it underground, is it in the water, the environmental conditions, so like what is the detonation site like, and the target, is it urban, is it rural, is it government, is it, can't think of another target right now, but I mean, so how big the destruction and how large the impact and all of that depends on a lot of things, but nuclear bombs have incredibly destructive forces and are releasing so much energy on such a big scale that every bit of their destruction is large, no matter where it's hitting and what it's targeting and the design. It's always going to be a large destructive because of the enormous amount of explosive energy that's being released. So yeah, that's nuclear bombs and weapons.